Okay, we're just going to look at some harder quotient rules. And the harder part is simplifying it at the end. So this is u over v. So the u is x squared minus 4, and the v is x plus 3 to the power of 4. The u dash would be 2x, and v dash would be 4x plus 3, all to the power of 3 times 1, because that's the derivative of what's inside. 4 times 1 is 4. Okay, so the actual rule is v. So the v's are all on the outside. Starts with v squared, v dash. Inside's u dash minus u. Okay, so when you're working this out, always start with the v first and then go to the u dash. So that's going to be x plus 3 to the power of 4 times 2x minus, and now I'm just going to take it to the other one, so the x squared. Okay, so it's going to be minus x squared minus 4 times v dash, which is 4x plus 3 to the power of 3. And this is all over x plus 3, this is v to the power of 4, but then it is squared. Now the simplifying part of this is what can be a little bit harder. You need to first of all simplify the top. So simplify the top just by expanding. Actually, you can't expand the whole thing, sorry, because they're big powers. Simplify the top just by gathering together all the numbers, get rid of any times. And then the next step is you factorize out the common factor. And then you cancel with anything on the bottom that is common. So when we look at this one, let's look at what is the common factors here. So you can see that, first of all, let's just look at the numbers. You've got 2 and you've got 4. So the common factor there would be 2. X, there's no common x. Okay, and then we go, all right, we've got x plus 3 to the 4 and x plus 3 to the 3. That's in both of them. So it's x plus 3 to that. Now you always take out the smaller indice. So the smaller one's 3, because x plus 3 to the 3 will be contained in x plus 3 to the 4. Okay, and there's nothing else that is common, so you've just got to look at what's actually left here. So 2 times, well the 2 came out, x is still there. That's just this x just here. And I'll just do it in red. Okay, that x stays. That one stays as well. So the x is there, and then there should be 1 x plus 3 to the power of 1. Because when you re-expand that, that's x plus 3 to the power of 3 times x plus 3 to the power of 1, which is x plus 3 to the power of 4. So take away. So here we have what's left. And we can see that there is, out of the 4, that's actually 2, because there's 2 came out the front out of that. X squared minus 4. And I'm just going to get rid of some of this so I have a bit more room. So x squared minus 4, so I'm just factorising it. And then we have, the x plus 3 all cubed. Actually, that all came out, so that can go. All over the bottom, which is x plus 3. Now you multiply those indices, the 4 and the 2. 4 times 2 will give you 8. Okay, so looking at that then, you can see that these will cancel and leave you x plus 3 to the power of 5. So then you are left with 2 is left. And then that inside here, that would be x squared plus 3x, and then minus 2x squared plus 8, all over x plus 3 to the 5. So I'll keep that factorised, 2x squared. So it's going to be, I'll just 3x minus 2, no, we'll make that 3x plus x squared minus 2x is minus x squared, and then it's plus 8. And that's all over x plus 3 to the power of 5. And that's your answer.